All right. We're going to take a look at Explore number 4 today. Um, we're going to be taking a look at Newton's universal law of gravitation, a formula that you've already been exposed to in the last lecture. So let's go ahead and draw our template lines out here, okay? Make sure you write the date. And go and draw a margin so you can make notes to yourself on the side or ask questions. We'll go ahead and take that green question there as our essential question. What factors determine the magnitude of the gravitational force between two objects? Okay. What factors determine how strong the gravity is, right? The magnitude, the strength. What factors determine the magnitude of the gravitational force between two objects. Okay. Got object A, you got object B. What makes gravity stronger between them? Or conversely, what makes the gravity between those objects less? Okay. So let's take a moment and write down what you already know. What I know or think. Okay. Go ahead and pause the video here. Write down a sentence, a couple bullet points. Don't have to make it very long. Okay, hopefully you've written something down. So let's go ahead and start taking our notes. We'll start by writing down gravitational forces. Recall from your previous readings and studies, gravitational forces are an attractive force between two objects. Okay. We had mentioned this earlier that gravity is described now using the theory of general relativity developed by Einstein, um, whereas the other three fundamental forces are lumped together in the Standard Model. Okay, we talked about that in the last couple lectures. But sentence number 2, Newton's laws of universal gravitation is still a useful rule, though, especially for day-to-day situations. Okay, and in green, you can see the law of universal gravitation is useful for describing the gravitational force attracting two large, slow-moving objects such as Earth and the Sun. Okay, gravitational forces. Newton's law of universal gravitation is useful for describing the gravitational force attracting two large, slow moving objects, i.e., Earth and Sun. Okay. Remember that the preference these days is to actually use Einstein's theory of relativity, but we can kind of default to this law by Newton because for simple purposes, it gets the job done. Okay, so you can see here on the left, there's the formula right there. Okay, and we wrote this in our notes last time. So we'll just go ahead and say B here. Okay, and it is the F of G is equal to G times M1 times M2, and all of that is going to be divided by the R squared. Okay, so what exactly are these things there? If we come back over here, we can see that the F of G, by the way, this is our force of gravity. The force of gravity, the magnitude, right? The strength of gravity between two objects. Force of force of I don't know why I said that. Force of gravity. Force of gravity. The magnitude. Okay. The force of gravity, or the magnitude, the strength between two objects. Okay. The G over here on the left-hand side is an actual constant. Okay, that's not going to change. Gravitational constant, which equals 6.67 times 10 to the negative 11, and that's going to be newtons times meter squared over kilogram squared. Okay. Now, if you're dealing with two objects, you need to know the masses of both of those objects. That's what this is. This is the mass of object one. Say you were talking about the sun. And here would be the mass of object two. Maybe that would be the Earth, right? Now, R actually represents the distance. Okay. But in this case, it's going to be the distance, and you're going to square it. The distance squared. Okay, a mathematical term there, right? Okay, and then they give us sample problems. And so I want you to go ahead and take a look at the sample problem here on the left-hand side. That's going to help you with solving the homework problems, okay? Remember, they can give you everything but one of these variables, and you can rearrange the formula algebraically to solve for any given variable, okay? All right. So I'm going to let you kind of explore that. But I do want to talk just a little bit about this formula before we let you go. Okay. So in this formula, the force of gravity is directly proportional to the mass of object 1 and the mass of object 2. Okay. I'm not going to say it's directly proportional to the gravity. The gravity is going to be constant all the time. So, what we're trying to say here is f of g is directly proportional to the masses of both objects. That should make sense. If the mass of object 1 increases, then the force is going to increase between the two forces, the force of gravity. If the mass of object 2 increases, then the force of gravity between those two objects is going to increase, okay? So we could say, and that's because these guys are in the numerator, okay? Okay. And I could extend this line all the way out if I wanted to, so it looks like this. That's fine too. Okay. But the denominator is a different story. Okay. The distance is in the denominator. Okay. So these values right here are in the numerator position. And remembering, digging back down to your math classes, the value down here, r squared, this is in the denominator. This is a fraction, right? So because the denominator, because this is a fraction, f of g is indirectly proportional. AKA indirectly related AKA, sorry to do this to you, inversely related. Inversely related to distance. And remember, distance is represented by the letter r in this case. Therefore, so if distance between the objects increases, if the distance between the two objects increase, then the force of gravity between them decreases. Then the force of gravity between them decreases. Okay? So as if r increases, then f of g decreases. Okay, that's an inverse relationship. As one goes up, the other one goes down. Okay, and that's something that you kind of were asked early on in your prior knowledge sort of questions. Okay, so let's go ahead and just leave that there for you for now. Okay, and again, you are going to need to look at this gravitational forces sample problem. Okay, so I'm going to just put a little star there. Okay, this is going to be, let me do this, letter D. I'll just put this, review sample problem from Explore number 4, okay, to do homework problems. Okay, so you're going to have these homework problems, and you're going to have to know how to use and manipulate this equation. All right, but I want you to spend some time doing that. All righty, we'll talk to you later. Bye-bye.